friends. Do you assign the minimum time to eat? No, you assign more than the minimum. Therefore, this model is quite interesting because it is accepting something that you observe in life, and second, you divide activities in two types. Those that you really want to stick to the minimum, like errands. Do you prefer to go to the bank to do your business or to do it by internet? By internet, of course. Well, something is old-fashioned. Let me show you. This is what do I have in my pocket?
A gun? That's why you prefer to go to the bank.
Let's improve that answer.
I cannot.
Something to keep my appointments, which is yeah, I don't have a cellular phone. I use this. So watch out. Some people say, so I don't use this. So if you want to meet me, I will write it down here, and you cannot call me 5 minutes earlier telling me that you cannot come. Or that the meeting is going to take place somewhere else. You see, I save a lot of time by not using a cellular phone. So this is the new model, and this is the model of that we defend. You might have noticed that I have carefully avoided any political joke. So far. The interesting thing is that with this model, something is wrong. There. So, if lambda is the multiplier of the budget constraint, mu is the multiplier of the time constraint in a normalization, written it in formal terms, right? And kappa is the multiplier of each of the technical constraints that relate time assigned to an activity and goods consumption in that activity, then we can define three values of time in this model. One is the value of time as a resource, which is mu over lambda. When you divide by lambda, you're turning all the marginal utilities in terms of time into money. Money per unit time, okay? So what is the value of time as a resource? Is the willingness to pay to have more time available. You might say, you cannot have more time available. I mean, a week lasts 7 days. That's by definition. Yes, but there is a multiplier. So you can think of a willingness to have a longer week to do more things. Okay, that's mu over lambda, value of time as a resource. Second is the value of time as a commodity. A better definition would be the valuation of the marginal utility of time, which is the marginal utility, in other words, the positive or negative number that you get when you take the partial derivative of utility, whether you like the activity or you dislike the activity, on top of lambda. This is the value of the marginal utility of that activity. Okay? And finally, and this is the novelty, the value of saving time in activity I. Because if you put this in normal terms, then kappa I is the value that you assign if you could reduce this by manipulating technically alpha I or AI, right? If you invent some, if you redesign a street and therefore the bus now takes less time, you're willing to pay to reduce that because you're taking the bus that is faster, correct? Therefore, you're willing to pay to reduce that. Now, these, you understand, are three ways of looking at time. The value of time as a resource, the value of time as a commodity, and the value of saving time in activity I. The relationship between these three is very clear. The value, this is only mathematics. The value of saving time in activity I is equal to the value of time as a resource minus the value of time assigned to that activity. Now, this is a much better explanation to what we believe is behind the value of saving travel time. Because this is representing the value of doing something else, and this is representing a term that is going to be more important, the more negative is this value. In other words, you're willing to pay to save time in an unpleasant mode, minus something that is minus is a positive sign. Okay, so this plays a role and this contributes to explain what I wanted to explain. But the second equation is very important. Mu over lambda is equal to this term here, and this is the wage rate, and this is the value of time of work as a commodity. In other words, it's the value of the marginal hour that you work, which could be positive or negative. Nothing can be said a priori. People expect that it's negative, and you're working only for the money, okay, in the last minute, but it not necessarily is so. It's subject to empirical investigation. Second observation, and this is an important one. What happens if you assign more time to what is minimally needed? When we were discussing the example of the youngsters getting together with their friends, they do not assign to eat exactly the minimum time that is required to eat the food. They assign more time because it's a very pleasurable activity, right? They assign more time that is actually needed. What is the value of the multiplier for that activity in that case? Out of complementary slackness, the value of the multiplier in that case is 0. If you assign more, this constraint is not active, therefore the multiplier is 0. If the multiplier is 0, it happens that the value of time as a commodity is equal to mu over lambda. Now, imagine that you have two activities that you assign more time than the minimum required. One is eating food with your friends, and the other is sleeping or resting in bed, reading a book, or thinking about this presentation late at night. Okay, you assign more time than the minimum required. In the first case, the marginal variation is equal to mu over lambda. In the second case, again the multiplier is going to be 0. So the marginal variation of utility is going to be mu over lambda. So at the margin, the two activities that you assign more time than required have the same value. The SERPA defines those activities that you assign more than the minimum time required as leisure. As all the activities that you assign more time than required has the same value equal to mu over lambda, the value of time as a resource was rebaptized as the value of leisure. So mu over lambda is the value of leisure. And now we can make the full interpretation. Here is the willingness to place to save travel time. The first term is the value of doing something else. And that something else can be leisure or work. Because in the right-hand side, you have the wage rate and the value of time assigned to work, which you can call the total value of work. The amount of money you receive, plus the value of the pleasure and displeasure at the margin that you get from work. And this has to be equal to the value of leisure. So, when we observe an individual, this has to work under an equality. So you can assign time to leisure or time to work. So the willingness to pay to save travel time is equal to the value of performing something else minus the value of time assigned to travel. We have solved the problem. We have solved the problem. The only problem is that when you estimate discrete mode choice models, what you estimate is only this one. So what's the value of this and what the value of that? You don't know.
Those are confounded.
You don't know. Yeah, you don't know. Which is exactly the reason why I didn't like the recent literature 2 years ago explaining that the coefficient of time could be positive because people like traveling, referring only to this term. But you have two terms. Yeah, people like listening to music in the car, so they like it. Yeah, the problem is, do you like it better than listening to the music in your living room in the house?
That is the two comparison.
Ah. Okay. So this simple expansion of the time-use model gives me a better explanation for the interpretation of the value of saving travel time. So what we did with Angelo Guevara, that has recently joined the group by the way, in March he begins with us, was the following. We expanded, we did exactly the same as Train and McFadden, a Cobb-Douglas utility function over all goods consumption and time, including work and travel, of course. These are the rest of the activities, with an income constraint, time constraint, and a very simple technical constraint saying that time has a minimum, travel time has a minimum. We were able to solve this problem mathematically such that we could calculate mu over lambda theoretically. So listen to this is very important, because nobody before could have explained mu over lambda. Here we estimate this model, beta and alpha are actually constructs that depends on these coefficients here. And you can calculate for every individual the value of leisure. With a discrete choice model, with the same data, you could calculate the willingness to pay travel time. And therefore, you can calculate by difference the third thing, which is the value of the marginal utility of travel time, the pure value of time while traveling in that moment. Okay, so we were very happy with this. However, this was published in 2003 after 2 rounds, and one of the referees was, we didn't get a closed solution at the beginning, and one of the referees said, you have this problem with these variables, it seems to me that you should be able to get a closed solution. And actually, we were able to get a closed solution. So we got it, thanks to the referee. So we rewrote the paper, we submitted again, and the editor sends only to this referee that was very persistent, fortunately. And the referee says, okay, I'm satisfied, the paper is fine mathematically, the paper is fine empirically. However, I have to add that I'm not convinced that people, because the essence of this model is to solve for the time at work. I am not convinced that you can have a labor supply model where the amount of time at work is depending on the time you spend traveling. We could have argued that, but I thought that this was reasonable. And therefore, we asked the editor whether we could acknowledge directly that referee if he or she was willing to provide his or her name. And it's happened that it was Ken Small. And that's the reason why we thank Ken Small. He was the referee. But we were actually uneasy with this observation. So what we did, we expanded the model. So with this new model, the first corollary is that pleasant travel is not enough for the subjective value to be negative, for the reasons that I have explained. Second, imagine that you had a budget. What would you prefer? To invest in more comfortable seats, or to invest in better routes to make, or better combinations of modes in order to make travel faster, or diminish travel time? But that would depend on the relative value of the first component and the second component. What is more important? That travel time is uncomfortable and pleasant, or that travel time is reducing the possibility of doing something else. So this is important from a policy conclusion. The third observation, which is exactly the point by Ken Small, now I can say, is that we have an implicit solution for TW, time at work, is a labor supply model that was impacted by travel time. We didn't obtain it in these papers, but you could actually get implicit solutions for leisure activities. It has to be solved. So our conclusion was, we have to expand this model to account for activities. And this was the beginning of the real story when we entered the world of time-use modeling in terms of travel time modeling only. In 2003, we made a step towards a general time-use model. The model was exactly the same. The only difference is that now we do not emphasize travel time. Now we care about all activities. So every activity has a minimum, every goods consumption has a minimum. And with the same mathematics, we were able to obtain an equation for the optimal amount of time at work, an equation for every leisure activity, and an equation for every freely chosen good. So we have a model that followed exactly the previous model, inspired originally by Train and McFadden, improved by the Serpa, and then formulated rigorously with Guevara, and ended with this paper with Reinaldo Guerra 2003. Actually, this was only in a conference. In 2008, this model was applied with real data. But this is the origins of the theoretical development. Okay? Now here, this labor supply model is more believable, because time at work depends on committed time, not only on travel time, on committed time, on the summation over all activities that you stick to the minimum, errands, transportation, and others that you stick to the minimum. And on the committed expenses. In other words, those goods that you have to buy mandatorily, and therefore you cannot take them into account when you have money to spend. Okay? You already discounted from income. So this is something that you're willing to believe as a labor supply model, and you have two more. Now, this is very elegant because from this model, if you can estimate all the equations, of course, if you have enough data, you can estimate the value of leisure, you can estimate the value of work, and you can check that this is happening, and therefore you can estimate all the values that you want. If you can add to this any discrete choice that you want to do, then you have all the values of time that you want. We thought that this was the end of the story. We were very happy. We estimated the value of leisure. For the first time. Okay, given that there are no applauses, I was very happy with this. Well, first, committed expenses and committed time play a key role in the model, and this is actually something that we should be troubled by, because you have to decide as a modeler a priori what is committed and what is not. Okay. Second, you require observations in a complete work-leisure cycle. You cannot model a day, because leisure here plays a key role. When you go to the supermarket,
Weekly data.
weekly data, weekly data, minimum, weekly data, because this is work leisure, okay? Because some people decide to go to the supermarket, at least in Chile, Saturday morning. Some people do it Wednesday night. Some people go Sunday afternoon, whatever. Okay, so it's a complete work-leisure cycle. So it is data consuming, data demanding. Okay. The third observation is that you have equations for time at work, you have equations for leisure time, and you have equations for goods consumption. So this looks like a reduced form of structural equations model, which actually played the role in some things that we did with the rampa and the ala that make this observation as well. You can calculate off the values of time that I showed earlier. This equation for TW is a more complete labor supply equation, and actually we did explore whether this view could be coupled with something else in order to re-examine the labor supply equations that you see empirically in the literature. We have not advanced that much, but I still have hopes on this side. Then, when you increase or decrease committed expenses or committed time, imagine that you liberate some of these committed things. Instead of going to the bank every day, you acquire your computer and you do it by internet. All right? That is a big change. So diminishing TC, and you can actually estimate the impact of that on the labor supply. Oh, this is an econometric observation because in fact you cannot estimate all the equations because one is going to be dependent on the others. Therefore, it's up to n-1 and contractivity, m-1 as constrained goods. And finally, this observation is not minor. This equation that looked very innocent, you can divide by the wage rate, and you can actually rearrange this such that this ratio plus that ratio is equal to 1. But this ratio is the value of leisure relative to the wage rate, which makes a better basis for comparison when you have data from different countries, for instance, or different segments of the population. Okay? All right. So now we have a time-use model. To summarize, if you have data on cost and time and other things, you can calculate. You can run the split choice models and calculate the willingness to pay to save travel time. That is hiding this equation. But what you calculate is only this part. But if you have good data on a weekly, at least weekly leisure work cycle, you have to have data on the committed time, committed expenses, the wage rate, the free time assigned to activities, and the free time assigned to work. Then you can calculate the value of leisure, and you can calculate all the inputs to have all the values of time. Data. How can you look at data? We began by collecting data in a corridor in the southern part of Santiago, and we did that with interviews at the workplace. Very rewarding. That was Pandido's recommendation. You go to the workplace downtown, you pick those individuals that live along the corridor, and then the boss would ask the workers to answer your survey. So they do it during work time. So the survey is marvelous. Okay, very small, but nice. So how can you represent this? Here, this is data contributed by the team of Kai Axhausen, Moby Drive. So this is Karlsruhe, this is a German city. This is Thurgau, a Swiss canton, and this is Santiago, a corridor to the south of Santiago. Have you ever been to Santiago? 6 million people.
6 million.
6 million people.
3 times Rome.
Yeah. No Coliseo. We're about to have 6 lines of the subway. The 6 are under construction. Very segregated. The northeastern part of Santiago is actually where the rich people live. Very skewed income distribution, that kind of thing. And this is what you can call a middle income corridor to the south of Santiago, served by a subway. Okay? Now, if you look at this, this is a way of describing time use in the 3 cities and canton. Here is the percentage of individuals engaged in a certain activity on a working day, on a Saturday, and a Sunday. Okay? So, blue line, just to let you know, blue line is being at home. So everybody is at home at 6 in the morning, or nearly everybody. This is weird. And, oh, they're having fun. This is out of home entertainment. Okay, but in Santiago, 100% is at home. Then they go to work. Why is this? Lunch. And in a nearby place, because they go back quickly to work, and they go home, and they stay there. So we're very boring guys, in essence, okay? Turgau is interesting because people begin going to work, and at lunchtime, most of the people leave, and
They go
home
home.
they go home to have lunch. Very civilized individuals, indeed. Excuse me?
Small town.
A small is a canton.
Ah.
So it's like a standard time, okay? And in Turgau, it's very peculiar, and then we can show averages. So this way you can describe the activities, and you have information regarding activities of any individuals in a cycle. Now, these are the values that we obtain applying our model to obtain the values of work and leisure in Karlsruhe, Turgau, and Santiago, and only in 2 cities we could obtain discrete choice model, mode choice models to work, because we had enough data, okay, in Karlsruhe and Santiago. And I'm showing this because when you look at the numbers, the value of leisure as a percentage of the wage rate, the value of leisure is larger in Turgau, is nearly 100% in the case of Karlsruhe, which means that the value of work is actually difficult to distinguish from 0. Okay? So we can claim that in Karlsruhe the Becker's model apply. Okay? But it's not the case in Santiago, where people is unwilling to work at the margin, and not that much in Turgau. Okay? Look at this. This is the percentage of importance of the marginal disutility of travel in Santiago and Karlsruhe. So this is 21%, and therefore this is nearly 80%. This is 71%, and therefore this is nearly 30%. In other words, relative to the wage, the willingness to pay to diminish travel time because you want to do something else is much larger in Santiago than in Karlsruhe. At first sight, if you had money, in Santiago, you better improve the system in terms of connectivity, speed, waiting time, etc., etc. And in Karlsruhe, invest in comfort. Is it reasonable? We believe it is very reasonable, because in Santiago, in average, an individual spends more than 2 hours per day, which is not the case in Karlsruhe. Okay? So this is the type of results that you can get by applying this model. Now, please don't get offended by this. This is true data. Karlsruhe, percentage of men and women involved in out-of-home entertainment. This is by gender. In Karlsruhe, Turgau, and Santiago. So in Karlsruhe, you can see that the red line is always on top of the blue line, in some cases, little exceptions. The same in Turgau, the opposite in Santiago. Can we conclude that in Santiago, women do not enjoy out-of-home entertainment? What?
Why?
No, I'm asking. Because here, women are always below men in terms of the percentage of women involved in out-of-home entertainment. And the opposite happens in Turgau and Karlsruhe.
I really think this is too aggregated data to tell what you're asking. Because it depends who's staying home and who's going out and where is going out. Because
This
the
is-
tent going out.
This is very strong data. My question is only, can you infer that women in that corridor in Santiago are less prone to out-of-home entertainment than women in Turgau and Karlsruhe? The answer is no, because this is a picture that is only showing you the basic distribution, but it's not capturing the model. Okay? We ran a model for Santiago with Marcela Munizaga, and I'm showing only the previous model that I presented in order to calculate the values of work and leisure for different sectors in Santiago. I told you that the northeast, here we call it the east, are the rich guys, the rich individuals, men and women, okay? Second, women are in a very high percentage the second income